All right, today we're going to be learning how to solve polynomials by factoring. So we're going to use all those 5 methods of factoring we just practiced and take it that one extra step and actually go to solving the polynomials. So for this first example, I'm going to give you kind of a step-by-step of what to do as we kind of do it. We're going to kind of analyze the graphs a little bit, and then we're going to do 2 more examples after this. So our first problem is 2x times 4x squared plus 25 equals 40x squared. So our first step is you want to get the equation in standard form. In other words, you want it to equal 0 here. So our goal is to get it equal to 0 and also get rid of any parentheses. So we're going to distribute that 2x. When I distribute that 2x times 4x squared is 8x squared. 2x times 25 is 50x. Oops, that's supposed to be x cubed. My bad, guys. All right, so now since we have to get it equal to 0, I'm going to move that 40 x squared. I'm going to put it in order, so it's going to be x cubed, 8x cubed minus 40x squared plus 50x equals 0. Okay, so that's step 1, get the equation in standard form. Step 2 is to factor out a GCF if possible. Now this won't always happen. Remember, we always check this as our first way of factoring. So I'm looking at this, I've got 8x cubed, 40x squared, and 50x. I definitely see a GCF. I think the GCF between 8, 40, and 50 is 2. And then the GCF between x cubed, x squared, and x is x. So when I factor out a 2x, I will get 4x squared minus 20x plus 25. All right, once we factor out the GCF, then we're going to completely factor. So using one of our other methods, we're going to factor it completely. We want to reduce each factor to an x or x squared. So you don't want to have anything greater than x squared left over here. So I'm going to look at this inside part right here. I need to factor that. So if I'm looking at it, it's got 3 terms. So I'm guessing we're going to have to use the trinomial method where we kind of guess and check. So I've got 2x, parentheses. All right, I'm going to ask myself, what times what gives me 4x squared? Well, I think 2x and 2x give me 4x squared. What times what gives me 25? Well, 5 and 5 does. And I wanted to get to negative 20. So let's see, I've got 5 times 2x, which is 10x. 2x times 5, which is 10x. If I want to make those into negative 20, I think both of those have to be negative. Okay, and I think that's completely factor because each factor is an x or x squared, because each of my factors is, this is factor 1, it's an x, so it's completely reduced. Another factor down to x, and another factor, so we're completely factored here. Our last one is we're going to set all the factors equal to 0 and solve. Okay, so each of my factors, I've got 2x equals 0, 2x minus 5 equals 0, and 2x minus 5 equals 0. So the first one, if I divide by 2, I get x equals 0 as one of my solutions. This one over here, I would add the 5 over and then divide by 2. So I get x equals 5 halves. And then I get x equals 5 halves again. So if you're looking at this, this is going to be a really important thing here. You want your degree to be the number of total solutions you see here. So if we look at this, so you want your degree to equal the total number of roots or solutions. Okay, so if you look at our degree from the beginning, our highest degree here is x cubed, so we should have 3 answers. And right here, we have the 3 answers, x equals 0, x equals 5 halves, and x equals 5 halves. Now you notice we have this solution twice. So how would I actually write this as a final answer? I would say x equals 0 and 5 halves, and I would call this a multiplicity of 2. Multiplicity just means it's happening twice and it's happening 2 times here. All right, so we have, in total, that would be my final solution there is x equals 0 and 5 halves, multiplicity of 2 because it's happening twice. So here's what that would look like as a graph. If we graph that real quick. Okay, we would have our first solution at x equals 0. Our second solution would be at 5 halves, that's at 2.5. Okay, and with this multiplicity, all right, since it happens twice, when it's an even multiplicity, it will look something like this. So it's going through that first one, touching this one, and rebounding off there. Okay, so this is what an even multiplicity will look like. It touches that x-axis and rebounds right off of it right away. It doesn't actually go through that axis. All right, let's try another example here. We've got 3x to the 7th minus 24x to the 5th equals 27x cubed. So step 1, we have to get it to equal 0, so I'm going to subtract that x cubed over. I get 3x to the 7th minus 24x to the 5th minus 27x cubed equals 0. Step 2, factor out GCF. Between 3, 24, and 27, I think the GCF is 3. And between x to the 7th, x to the 5th, and x to the 3rd, I think x cubed is going to be our GCF. So when I factor that out, I'm going to get x to the 4th minus 8x squared minus 9 equals 0. All right, so now I'm going to look at this in here. Again, I've got 3 terms, so I'm going to do my trinomial and my guessing check method when I factor. What times what gives me x to the 4th? Well, x squared. What times what gives me 9? I'm looking for 3 and 3 gives me 9, but I don't think 3 and 3 will get me to that 8. So I'm thinking it's probably going to be 9 and 1. So I'm going to say 9 and 1. So right now I've got 9x squared and x squared. If I want to make that negative 8, it needs to be a negative 9 and a positive 1. So now I've got 3x cubed x squared minus 9 x squared plus 1. But I don't think we're completely factored yet. If I look at here, I think that's difference of perfect squares. So I think I can factor that one out more. Remember, difference of perfect squares, right, is when you do x times x. What gives you 9? 3 and 3. One's plus, one's minus. Now I think we are truly factored all the way. So now we're going to set all of our factors equal to 0. So I've got 3x cubed equals 0, x plus 3 equals 0, x minus 3 equals 0, and x squared plus 1 equals 0, and we're going to solve. This one I'm going to divide by 3, so I get x cubed equals 0. All right, since it's x cubed, that's technically going x times x times x. So there's 3 x's here, so that means that x is going to equal 0, and I'm going to call this a multiplicity of 3, because there's 3 of them there. This one's going to give me x equals negative 3. This one gives me x equals 3. This one, I'm going to subtract that 1 over, take the square root of both sides. The square root of negative 1 is just plus or minus I. So what I would do here, I would say that my solutions, or my roots, okay, I get x equals 0 with a multiplicity of 3. I just say m of 3 sometimes. I've got x equals plus or minus 3 there. And I've got x equals plus or minus I. So let's double check that we got all of our solutions. So I've got 3 here in this first one, 3. I've got 4, 5, 6, 7. My highest degree, remember, was a 7, so I've got all my solutions. Now here's what an odd multiplicity is going to look like on your graph. All right, so we know we have solutions at x equals 3, an odd multiplicity. We know we have it at plus and minus 3. We have that plus or minus I, which we won't be able to see on the graph, but it'll look something like this, where it changes. All right, so it's going from increasing or decreasing, still going to increasing because that what we call like an inflection point. All right, so this is what an odd multiplicity will look like. Okay, so if you see a graph, this is an odd one will look like it and keep going through like that. All right, whereas an even one bounces right off of it. All right, let's do one more example here. I've got negative 4b to the 4th equals 500b. So I'm going to subtract that over, that 500b, to make it equal 0. All right, I'm going to pull out GCF. I think my GCF here is negative 4b. So I've got b cubed plus 125. Let's check in here. So I'm looking at this. It's two terms. So it's either going to be difference of squares or sum of difference of cubes. I see b cubed and 125, so I'm thinking it's going to be our cubes. So for that one, my cube, it's going to be b plus 5, b squared minus 5b plus 25. Okay. We will not be able to factor this trinomial more when we use that sum or difference of cubes equation. So now let's set all of our factors equal to 0. Divide by negative 4 here, and I get b equals 0. Subtract 5, I get b equals negative 5. And over here, I'm going to have to use the quadratic formula, so b is going to be the opposite of b, which is 5, plus or minus the square root of negative 5 squared minus 4. My a value is 1, my c value is 25, all over 2 times my a value. That gives me 5 plus or minus that square root becomes, oops, sorry guys, negative 75 all over 2. If I simplify that square root, all right, I get 5 plus or minus 5i radical 3. That's bad. All over 2, and that can't be simplified anymore. So I would say my solutions are b equals 0, negative 5, and 5 plus or minus 5i radical 3 over 2. Let's double check we have all of them. All right, so I've got 1, 2, 3, 4 there, and my highest degree is 4. So we're good to go.